There are lots of things all around us, exciting things that surround us.
But how does it work?
Do you know?
How is it made?
Do you know? Things that go up, things that go down, things that go pop, things that go round, with special cameras to show you inside. It's going to be a big surprise.
But how does it work?
Do you know?
How is it made?
Do you know? Do you know?
Let's find out!
Oh, hello, I'm Maddie, and today I'm washing the dirty dishes in the sink. Do you help do the dishes? At home, we use water in lots of different ways, don't we? We use it to wash up, cook, clean, and drink. But how does the water come out of the tap ready to drink? Do you know where clean water comes from? Let's find out. How does it work?
Clean drinking water.
To find out where drinking water comes from, I'm starting at a reservoir. A reservoir is where lots of water is stored to be used in our homes. Where does all this water come from? Some water comes from the land. When it rains, the water runs off the land into the rivers. Some water comes from under the ground and out of small holes in the earth called springs. And some gets recycled after it's gone down the plug hole. But how does water from all these places get to the reservoir into our homes? Where does it go? Can you hear that sound? All of this water has travelled through drains and pipes from our homes. Sounds like a waterfall, doesn't it? Well, this is called a water inlet. And all of the water rushes down there and it ends up in here at the reservoir, along with all the rainwater and the spring water. But where does the water from the reservoir go? Over there is a tower called a draw-off tower, but we can only see the top of it. The rest of the tower goes 20 metres down underwater. That's about as tall as 4 giraffes standing on top of each other. Look how tall it is. And I've been given special permission to take a look inside. The draw-off tower is where all the water from the reservoir is taken out to be cleaned. Wow, I've got to get all the way down there. Inside the draw-off tower are pipes, and inside the pipes are valves. The valves open and close, and when they open, water can rush through from the reservoir through the pipes. When they close, the water stops. And when the valve opens, the water moves along the pipes to here. This is the water treatment plant. And here there are different types of tanks where the water from the reservoir is cleaned so we can drink it. But to find out how the reservoir and the water treatment plant work together to get the water really clean, I think we need to take a closer look. The reservoir collects water from natural springs and rivers, the rain, and water inlets. A draw tower opens its valves, which lets water from the reservoir travel down pipes to a screen that filters out any litter or waste. The water passes into the water treatment plant and goes through 4 different cleaning tanks that make our water really clean before travelling along pipes into our homes. So we can drink clean water from the tap. That was so interesting. And here is our first set of cleaning tanks. They're called flocculators. What a funny name. Inside the tanks, the water is mixed with a liquid called ferric, and ferric has bits of iron in it. The iron works like a magnet, collecting all of the dirt and grit that's in the water. And these paddles help to mix the dirt in the water with the ferric before it goes inside to the next set of tanks. To get the water really clean, air is pumped into the bottom of these tanks. They're called dissolved air flotation tanks. Can you see that the water at the top of the tank is brown and foamy? That's all the ferric with dirt stuck to it. And over there, those are skimmers that are skimming the sludge off the top. But I wonder what's happening underneath the water. Time for one of my special underwater cameras. Okay, we're recording, which I've attached to a long pole. Look at all those bubbles. The air is pushing dirt from the bottom of the tank to the surface. So it goes really brown and sludgy on the top. Watch what happens when I put the camera in the water. It still looks brown, but can you see all the lumps are floating up to the surface, ready to be skimmed off by the skimmers. Next, the water is pumped outside to these huge tanks to be cleaned even more. These tanks are full of this stuff. It's called carbon. And carbon is a natural material, and it's got a really lumpy, bumpy surface. The water passes through the carbon, and any chemicals that we can't see in the water get trapped in all of those lumps and bumps, leaving the rest of the clean water to filter through, ready for the final stage. This is called disinfecting, and inside those pipes, anything that is not good for us to drink is taken out of the water. And now the water is clean. From here, the drinking water is pumped through underground pipes and is kept in storage tanks that will hold the water till we're ready to use it in our homes. I loved finding out how we get clean water. What was your favourite bit? Can you remember the name of the building that takes all of the water from the reservoir? That's right, it's the draw-off tower. Did you hear all the water rushing through the water inlet into the reservoir? Sounds like a waterfall, doesn't it? And did you see all the bubbles on my special camera in the dissolved air flotation tanks? Did you know that plants and trees get the water they drink from under the ground through their roots? Some vegetables even grow underground, just like these vegetables. But what are they called? Carrots. But how does a carrot grow under the ground, and why is it orange? Do you know how a carrot's made? Let's find out. How is it made?
Carrot.
To find out how carrots are made, I've come here to a carrot farm. Every carrot starts out as a tiny seed like this one, and it grows into a carrot that we can eat, like this. Most carrots are orange because they contain lots of a natural chemical called beta-carotene. Beta-carotene is a reddish-orange colour, and it's also the reason why carrots are so good for us. When we eat a carrot, our bodies take the beta-carotene and they turn it into something called vitamin A, which is great for our eyesight. But how does a tiny seed grow into a yummy carrot? First, it needs to be planted. To plant this entire field is going to take a really long time. So we need a bit of help with one of these. A tractor pulling a special machine called a seed drill. You should never play on or go near farm machinery without a grown-up, but I've got special permission to show you how it works. This is a seed hopper, and if we take a look inside, there are thousands and thousands of carrot seeds. But look, they're green. The seeds have been dyed green so the farmer can see where they've been planted because they're so tiny. Now the seeds, they're sucked onto this disc into those tiny little holes, and the disc spins around, and then the seeds are knocked off one at a time at the bottom so they're perfectly spaced apart in the soil. Should we see it in action? The seed full of seeds and can plant 5 million seeds every hour. When the seed is in the ground, it soaks up water, and after about a week, a root will grow down and a shoot will pop up above the soil, and this stage is called germination. After around 3 months, that little shoot turns into these big green plants. It's like the carrot's fluffy hairstyle, isn't it? But what does a carrot need to grow? The leaves collect sunlight, and at the same time, a gas called carbon dioxide, which is in the air all around us. And the carrot roots collect water from the ground. The sunlight, carbon dioxide, and water all work together inside the carrot to make food, so the carrot can grow. It's called photosynthesis. To see the carrots underground, I'm going to use one of my special cameras. This is called a probe. It's perfect for finding carrots because it's bendy and it can get into lots of unusual places. Look, it's like a wiggly worm. Right, let's see what we can find. Whoa! Can you see the tiny baby carrot going in the ground? I wonder how deep the root goes. Let's move this a bit. You see all of those wiry little hairs? Those are more roots that are sprouting out of the sides of the carrot. This is how the carrot gets water from the soil. I think these carrots have a bit more growing to do though, so I'm going to leave them where they are. But what happens to the water once it's inside the carrot? Here we go. This part of the carrot is called the central core, and inside the central core is something called xylem. It's the xylem that carry water all the way up to the leaves, so the carrot can grow. Works a little bit like a straw. Clever, isn't it? After 5 months, the farmer covers the carrots in straw to keep them warm until they're ready to be picked. This is a harvester, and I've been given special permission to jump on board and see the carrots that have been pulled up out of the ground. The harvester digs into the ground underneath the carrots and scoops them up into the harvester, where they go up a lift and come out here onto a conveyor belt. They go along this wobbly conveyor belt that jiggles all of the dirt off them. Can you hear it? The carrot then finishes its journey by dropping into a big container. That was brilliant. And here's one now. I loved finding out how carrots are made. What was your favourite part? Do you remember the name of the machine that planted the seeds into the ground? That's right, it's called a seed drill. Did you hear the sound the conveyor belt made on the harvester? And did you see the tiny carrots growing underground on my special camera? So the next time you see carrots at the shops, you'll know how they grew underground. And when you have a glass of water from the tap, you'll know how it was cleaned, so it's safe for us to drink. I'll see you next time. Hello, I'm Maddie, and today I'm looking at the sky through my telescope. When we look through a telescope, we can see things that are really far away, close up, like those clouds and the tops of really tall trees. When we look through a telescope at night, we see different things, like the moon and the stars. And can you see that really bright dot in the middle? That's a planet. The moon, stars and planets are in space, and space is all around planet Earth where we live. But there are some things in space that are so far away we can't see them even if we use a telescope. So we have to use something else. This is a different type of telescope. It's called a radio telescope, and it's huge. But do you know how a radio telescope works? Let's find out. How does it work?
Radio telescope.
To find out how a radio telescope works, I come to an observatory. Wow! This radio telescope is so big. It's 38 metres wide. That's the same as 15 cars parked next to each other. A radio telescope collects radio waves to find out where things in space are. Radio waves carry energy through space, but they're invisible. We can't see them with our own eyes. They travel from space to Earth, but because they travel such a long way, they're not very strong or easy to find. So that's why we need something this big to find them. This part of the radio telescope is called the dish. And can you see the white box in the middle? That's called the receiver. But to find out how the dish and the receiver work together to collect radio waves, I think we need to take a closer look. Stars, planets and galaxies give off radio waves that travel through space towards Earth. Some radio waves hit the radio telescope. They bounce off the dish and into the receiver. The receiver turns radio waves into signals and sends the signals along cables to a computer. The computer turns the signals into colours. So we can see the radio waves as a picture. Scientists use the pictures to help us learn how far away planets, stars and other galaxies are. That was amazing. But to collect radio waves from galaxies, stars and planets, the radio telescope has to be able to point at different parts of space. The radio telescope can move up and down, round and round, but because it's huge, it moves really slowly. So I'm going to film it moving with some of my special cameras. And this special camera is going to record a time-lapse, which lets us see slow things happen much quicker. All set? Look, can you see the radio telescope moving? Isn't that brilliant? Oh, look at it now! It's turning around and collecting radio waves from space. Radio telescopes can be found all around the world. These ones are in America, in the mountains. And these radio telescopes are in the desert, and they work together to collect lots of radio waves at the same time. But how do all these radio telescopes know where to point? This is Ollie, and Ollie is a controller. It's his job to watch the telescopes and make sure they're all pointing the right way so they can collect radio waves from space. The radio telescope collects the radio waves and the receiver turns them into signals. Those signals get sent through cables to these computers. Can you hear that whirring sound? That is the noise of these computers working away. They collect signals from lots of different radio telescopes and send them to a supercomputer that's so special it stays locked behind this door. And this takes all of that information and turns the signals into a picture using different colours. Now let me show you something really special. This is a photograph of a galaxy. The galaxy is made up of lots of stars, planets and dust. Planet Earth, where we live, is in a galaxy called the Milky Way. This is a photograph of the Milky Way. It's beautiful, isn't it? But the pictures a radio telescope and a supercomputer make don't look like normal photos. The pictures they make show planets and galaxies as colours. Can you see the bit in the middle is red? That's because there's lots of radio waves, which means that's where the stars and planets are. How brilliant is that? I loved finding out how a radio telescope works. What was your favourite bit? Do you remember remember what the part of the radio telescope is called that collects the radio waves? That's right, it's the dish. Did you hear the sound of the computers that collect the signals from the radio telescope? And did you see the radio telescope spin around to find the radio waves on my special time-lapse camera? So the next time you look up at the sky, you'll know how a radio telescope works to find stars and planets that we can't see. Can you think of any games we might play where we need to find something? How about hide and seek? Here I am! Hello! Or how about a maze? A maze is a puzzle with lots of different paths, and we have to try and find the middle or the way out. Wow, look how big it is! Do you know how a maze is made? Let's find out. How is it made?
Maze.
All mazes have a middle, lots of paths, an exit, a way to get out, and an entrance, a way to get in. The rules of a maze are simple. Find the middle by choosing the right paths. Shall we give it a go? And I'm wearing one of my special cameras so you can see what I see. First, we go through the entrance. Look, there are lots of paths leading in lots of different directions. Oh no! Wait, can you see? There are some places where paths meet. When two paths meet, we say it's a junction. I think we should go left. Go on, this way. It's a blocked path. It's called a dead end, and it means we need to go back the way we came. Where are we going? We must be nearly there. Yes! Woo! We found the middle. That was so much fun. There are big mazes like this one, but you might have played with a small maze instead, just like this one. This small maze works in the same way as the big maze. Can you see all the paths and junctions? But instead of me trying to find my way around it, it's got a small metal ball inside called a ball bearing. But do you know how a wooden maze like this one is made? Let's find out. But first I need to try and find the exit. To find out how a wooden maze is made, I've come here to a craft workshop. Making a maze starts with one of these. It's called a maze blank. Can you see that it's made up of lots of circles inside each other? 1, 2, 3, 4, 5. We call these concentric circles. The green line on the outside will become the outside of our maze. This is where the entrance and the exit will be. The black lines, they show us where the paths of the maze will be. But how does a maze blank turn into a maze? First, the maze blank goes on top of a light box like this, and then a piece of plain paper goes on top of that. The maze design is drawn on plain paper laid over the top of the light box. This means the design can be drawn using the circles as a guide. Whoa, there we go. This is called our path map. The path map shows us the correct path through our maze. Next, we need to copy the path map onto the maze blank. To do this, we use little pieces of black tape to make the junctions. Can you see they're being placed over the lines drawn onto the maze blank? And then white tape is used to block the path and make dead ends. Wow! So this is our finished maze design. It's got lots of different paths, junctions, and blocked off paths. But to make a wooden maze, the path map needs to go onto a computer. And here it is. This is Russell, and Russell sends the image of the maze path to this machine. It's called a CNC machine, and its job is to carve the maze path into the piece of wood. Shall we see it in action? operator is telling it where to cut. The end mill tool moves really quickly, so to see how it carves the maze path into the piece of wood, I'm going to film it using one of my special cameras. Right, ready when you are, Russell. My special camera lets us see things that happen quickly, much slower. Can you see all the little wood shavings flying off? Think a bit like little fireworks. And just like fireworks, really noisy, isn't it? Wow, look at this. All the different paths have been carved into the piece of wood to make our maze. All I need to do is pop in the ball bearing and we have a maze ready to play with. I loved finding out how a wooden maze is made. What was your favourite bit? Do you remember the name of the place where the paths join together? That's right, it's called a junction. Did you hear the sound the CNC machine made as it cut out the maze path on the wood? And did you see on my special camera how I tried lots of different paths inside the maze before I found the middle? So the next time you play with a maze, big or small, you'll know how it's made. And the next time you look up at the night sky, you'll know how a radio telescope works to help us learn more about other planets, stars, and galaxies. Right, I'm gonna have another go with this little maze. I'll see you next time.
There are lots of things